Hey, everyone. It's really, really good to be here and see every one of you. Absolutely great. Thank you. So yeah, I'm from Berlin, Germany, and I'm bringing you today lots of Robot Framework love. Well, this is about infrastructure as code, which I believe could be the next superpower for your test automation. I'm Niels, as you already heard, and I work as a QA engineer at Humanitech, which is a member of the Robot Framework Foundation. Yay! Such a good mood. All right, it'll get even better here. So I'm guessing that some of you might be able to relate to this meme. Maybe you can even raise your hand if you're using any kind of cloud infrastructure in your daily job. I would be really interested to see that, actually. Yeah, I kind of guessed it would be most of the room, but it is actually, so you're in the right place. Running your stuff in the cloud got so easy, right? And you only have to pay for it while you use it. But, well, Amazon, just because I forgot to switch off that virtual machine does not mean I still use it and want to pay for it. But yeah, staying on top of your cloud cost can be tricky. But I need all those Kubernetes clusters and databases and storage buckets and DNS records for my tests. Otherwise, they won't run. So I better prepare for the incoming cloud bill. And for some reason, I get quite the high cloud bill for my test infrastructure. It was just a couple of €1,000 per month, but my manager seemed somewhat unhappy with it because it was almost as much as we pay for our production infrastructure. So I don't know. Well, let me explain you a bit why I paid so much for cloud resources, right? So at Humanitech, we develop several products to enable software development teams to self-serve infrastructure via a platform orchestrator. So that's one of our products, right? And with that, we offer a lot of integrations. So platform engineering teams can basically connect their cloud resources to our system. And that means a lot of integrations to test for me. So we obviously integrate with the big three cloud providers like Google, AWS, and Azure, but we also need to make sure that other Kubernetes flavors work like OpenShift and that we are also supporting like smaller cloud providers like Civo, for example. And then there's many different CI tools, and those CI tools usually at some point you build artifacts and you need to push them to container registries, right? So we need to support like also a couple of container registries. And then before any deployment happens, there are different infrastructure code tools which set up infrastructure for you through Humanitech and through the platform orchestrator. And those infrastructure pieces could be like databases, and there could be like many different kind of message queues and message brokers. There's cloud storage involved, application secret management systems. And when it comes to networking, I need to support like different kinds of ingress controllers and also DNS management tools. So this is a lot, but even that's not all of it. Like we are also providing Kubernetes operator, several Helm charts. We develop our own Terraform provider at Humanitech, and so on. So there's so many things to test, and it's hard to stay on top of that. And I wish that would be my only problem. Maintaining all of this is a true nightmare, I can tell you. Once it's set up, my tests rely on it, so I need it. It needs to be there in order for things to pass. And as soon as someone from the team changes something or an update from a cloud provider is performed, my test might start failing. And then it's often hard to understand, why is that the case now? Why are things failing? What was changed? And I also have no record of how it was set up before. So that kind of sucks, and I don't know what to do. So the actual state of the configuration is drifting away from how it was set up initially. But don't you worry, there's infrastructure as code coming to the rescue. So at Humanitech, I was involved in developing a disaster recovery plan for our production infrastructure. Infrastructure as code helped with this a lot, as it made changes auditable, and we could quickly recover any part of our infrastructure setup. It also became clear that our test infrastructure is also critical to us. With continuous deployment, we ship tested code changes several times a day. And without that, we can't do that, right? So it's critical. Since we store the setup of our test infrastructure in Git repositories, we now need a pull request to change anything. It needs to be reviewed and then merged. When we are talking about infrastructure as code, it's important to understand that there are two main approaches, one called imperative and the other one declarative. An imperative approach defines specific commands needed to achieve desired configuration, and those commands need to be executed in the correct order. With a declarative approach instead, it defines a desired state of the system you want to create. In most ISC tools, they basically prefer one way over the other, essentially. And on top of that, there's also many different flavors when it comes to infrastructure code tools. Mostly common is Terraform from HashiCorp, a company also known for its secret management tool called Vault. And it's important to understand that HashiCorp they changed the license for Terraform from a public license to a business source license. And from that point on, the community was so nice to start maintaining a fork called OpenTofu. And this is obviously because it's a fork, it's mostly compatible and well maintained by the community these days. And the reason for that is because HashiCorp is currently in the process, and it's a pretty long process, of being bought by IBM currently. Other than that, there is IAC tooling from each cloud provider, right? So there's at AWS, you find the Cloud Development Kit, CDK, or AWS CloudFormation. There's Google Cloud Deployment Manager, and there's also Azure Biceps. On top, there are a couple of more cloud-agnostic IAC tools, like Pulumi, for example, which I think is worth mentioning because it uses common coding languages instead of script or YAML files. So you can basically write your IAC code in Python, in TypeScript, Java, or Go, for example. And then there's also worth mentioning Crossplane, which is basically using Kubernetes manifests and operators in order to create cloud infrastructure. So also interesting to look at if you're ever looking into infrastructure as code tools. I also need to mention that there's a couple of older, maybe more mature, IAC tools like Ansible, Chef, and Puppet. Those mainly follow an imperative approach, but they can be also used in different ways. In the end of the day, at Humanitech, we decided to use a declarative approach with Terraform. And this is what I want to focus on today. So, using Terraform for my test infrastructure helped with the configuration drift, as I could see now all changes in the code. But I still had kind of a high cloud bill because it was still the same infrastructure, right? So I needed to be more flexible and more dynamic with my test infrastructure. The idea was to only create it when I actually need it in a test. It was time to use Terraform within my Robot Framework tests. You see the little plant growing there? Awesome picture, right? Each test should create the infrastructure it needed first, run the test on it, and then tear it down again, so I don't have to pay for it anymore. And at this point, with the help of Manny's talk from RoboCon 2022, I created my own library and called it the Terraform Library. And this was an absolute great experience. I was able to build and publish the first version of my library to PyPy within 2 days. So kudos to you, Manny. I can highly recommend it. So it's time to look at some code, guys. Let's have a look at the Terraform library. I compiled a small example here for you, and I'm going to walk you through the example itself, through a little bit of Terraform script, and then we'll look at some of the outputs to really understand what's happening there under the hood and how it looks basically. So the idea here is to create a virtual machine, connect to it via SSH, and then remove that machine again after a quick validation. And I'm going to use the SSH library for the SSH connection. And I'm going to use the Terraform library to create an AWS EC2 instance, which is essentially just a virtual machine you can rent per hour from Amazon. When importing the Terraform library, wait, that's the wrong button. When importing the Terraform library here from the keyword documentation, I'm basically overwriting the executable to Tofu, because in this example, I don't want to use Terraform, but I want to use the open source version, which is fully compatible, called OpenTofu instead. After creating the instance via the Terraform script, which I'll show you in a bit, we'll extract some details from the Terraform state. With that information, we can then connect to the instance via SSH, where we can get the host name. Finally, we'll compare the data from the Terraform state to the host name and then remove the instance. That's it. So let's have a brief look at some of those keywords. To run a Terraform script, we need to run Terraform init first. Here, we pass on the path to the script. It will then initialize your working directory and download all provider code. More about that when we look at the report, the test report. We then write the output to the test report with log, and in case of a negative return code, we basically use a fail keyword to elevate the error details. Usually when you run Terraform manually, you would first do Terraform init, and then you would do a Terraform plan. And that would basically give you an overview of what's going to change. But since we are using this here in an automation script, we don't need to review a plan manually. We can straight go to Terraform apply. And this will apply all changes necessary to create the desired state described in the Terraform script. Remember, this is declarative, right? So we have a description of what we want to create. And we'll look at that in a second. And then in the Terraform state, all details about the created resources are stored. This information is available in JSON format. And here we extract the public and the private DNS of that instance. So we establish the SSH connection. We have the public DNS of that instance, which we just got from the state. And then we log into the instance using the private SSH key. In the SSH session, we then run echo hostname to obtain the hostname of the machine. And then in the verification step, we compare the private DNS from the Terraform state with the extracted host name we just got from that SSH connection, and expect it to be the same. And then finally, by executing Terraform destroy, we remove everything which has been created. I think it's a rather simple test. Let's have a look at the Terraform script itself, because this is just like a wrapper around it to execute the Terraform script, right? So, looking at Terraform at the very first time, this might look a little bit like a wild mix between JSON and YAML. Terraform calls it HCL, which stands for the HashiCorp language, but I think it's still readable. So, first of all, you need to import the required providers, which is kind of similar to importing libraries in Robot Framework, right? So here we use the AWS provider, as we want to create a cloud resource in an AWS account. We configure the cloud region and also which access profile should be used. And next, we define a resource of type AWS instance, and we call it Robot EC2 instance. On the details, we have the Amazon machine image, AMI, which basically refers to a Linux image provided by AWS in this case. And then we have the instance type, T2 micro, and that basically refers to a virtual machine with 1 CPU and 1 GB of memory. It's kind of the size of the machine. And then the key name refers to an SSH key pair, which is already existing in the AWS account. And this is passed on as a variable. So you see there this different kind of notation, basically. And we also need to define a subnet ID to tell Amazon in which network or VPC this instance should be created. So there's a couple of things which need to exist basically in your AWS account to just create an EC2 instance, right? And last but not least, there's also the security group mentioned, because this is basically where it's defined how this machine can be accessed. And I need to have port 22 open for an SSH connection, obviously. So all details to any resource are well documented in the Terraform registry, right? So you have like anyone who's providing a Terraform provider, they basically upload it to a Terraform registry, and there's one available at the HashiCorp website and one at the OpenTofu website, basically. And there you can see like kind of like keyword documentations in Robot Framework, and basically what are the inputs and the expected outputs, and everything is really nice and clean defined. So it makes it, in my opinion, quite easy to work with it, even if you come to it for the very first time. This is just the last part of the Terraform script. We need to define some outputs and input variables, basically. So anything mentioned as an output will appear a little bit more prominent in the section of the Terraform state. And there we want to have basically the public DNS and the private DNS, because we want to use that in our Robot Framework script. And anything we are passing on into the script needs to be defined as an input variable, basically. I think it's pretty nice that it's possible to add descriptions to any of those elements. It makes the Terraform script itself quite readable, in my opinion. So let's run the test. That was pretty quick. Well, luckily it's not a live demo. So great that our test passed in record time. Let me show you a little bit more details from the test report. Okay. It looks like the test took about like 2.5 minutes. Let's concentrate on some of the details from the Terraform execution, right? So if we scroll here to the example of Terraform init, we can see that it initialized the backend where it stores the Terraform state. And this is basically just a local path here, in this case, in the file system. And it downloaded the AWS provider. And we also can see that it successfully initialized OpenTofu. So it's not using Terraform, but OpenTofu instead in this case. And then if you go down to Terraform apply, it tells us what it will create, right? So it tells us it will perform the following actions, and in this case, creating an EC2 instance. There's lots of details to an EC2 instance showing in this test report. But the important bit here is, when I'm scrolling further down, is the summary then of the Terraform plan. So it always shows a plan of what's going to happen, even if you just do apply. And it tells you that it will add 1 resource, change 0, and also destroy 0. Thank God. At this point, it just should create something, yeah. And we can see that the creation was completed within 14 seconds, which is pretty fast to just stand up a virtual machine and run stuff on it, I think. And and the apply completed was adding 1 resource. And in the end, we also can see the outputs where we can see now the private DNS, so the internal address to access that machine, and also the public DNS to access that machine, which we then use in the verification step. And then after the verification step happened, we run Terraform destroy, and it also informs us about the actions it will do. So scrolling down to the end then successfully shows the destruction of one resource after 1 minute and 11 seconds. The times here can vary sometimes a bit. It's always depending on the availability of the instance type in the AWS region and also on the responsiveness of the AWS API, right? You need to keep in mind you're dealing here with third-party APIs in the end of the day. But yeah, that worked quite nicely. So, congrats everyone. You made it through the code examples. And you also reached the beer slide, so welcome to that. Maybe it's a little bit early, but I don't mind. So there's only 3 more slides coming, so please bear with me a little longer while I want to bring a few points across. Handling AWS EC2 instances is just one small example of what's possible with Terraform and OpenTofu. There's a huge variety of Terraform providers available. Like apart from handling cloud resources from really any cloud provider, you can find providers for Kubernetes to handle Kubernetes objects, very similar to the Kube library, but that's a different topic we're not talking about today. There is a provider for Helm charts, for GitHub and GitLab to deal directly with your repositories, for example. There's one for Docker, where you can build images or pull images or interact with container registries, for example. And I've even seen one for Spotify, where DevOps teams seem to manage their Office playlists with. But yeah, that's all possible with Terraform. You're different. Nonetheless, dealing with infrastructure as code and learning Terraform can be quite challenging. But I have to say it's well documented with a helpful community. You see the reassemblance here? In addition, as a test engineer, you can approach Terraform differently than a DevOps engineer does, especially if your test infrastructure only needs to be available when your tests run. DevOps or infrastructure engineers usually need to care about a lot about state files. They need to store them, they need to keep them in sync and with actual infrastructure and keep them in sync with the actual infrastructure state to prevent any kind of configuration drift. Handling state can be a big pain, and you should only do it if you really need it. In my case of testing all the integrations for Humanitech, you still remember the slide with the many logos, right? It feels quite extensive. But when you run on cloud infrastructure, sooner or later, you'll come to the point where you need to reduce your cloud bill, or you suffer from configuration drift, for example. And infrastructure as code is a great tool to deal with that. Let me give you a little bit of an outlook. So what's coming next for the Terraform library? It's currently the configuration for some of the Terraform executions. They rely on environment variables. And I identified this as a problem when running like several of those tests in parallel, because obviously environment variables, they are shared across threads, right? So I'm planning to further improve with the next release the running of Terraform library tests by basically passing on configuration via the Terraform execution in the command line parameters instead of using environment variables. And I'm also hoping for more usage and that you maybe try it out if it suits your use case, and hopefully some feedback from you. Maybe in 1 or 2 years, we can even do a workshop. Who knows? With that, I hope you enjoy the rest of RoboCon. Thank you very much.
Thank you, Niels.
Thanks.
Favorite beer?
My favorite beer?
Yeah.
Ooh, that's a tricky one.
Okay, top.
Yeah, so there's one from a city called Bremen, which is called Hakebeck Kreuzen. It's an amazing beer. Like I
write it down.
And that one.
Yeah. Humanitech.
Yes.
Yeah, I misheard the company name many times. Backstage, I thought Moneytech. There's like
Money,
let's
yeah.
go. Ed and me were chanting like USA, USA backstage. But yeah, Humanitech, 1 or 2 questions. Who has questions there back? Let's take that and we'll get rid of that.
You don't want to hurt anyone anymore? No.
Here, thank you for the presentation.
Yeah.
I will actually say this is actually good. I made a presentation yesterday about RF-Swarm and actually actually deployed my agents in EC2 instances, and I literally had to manually create EC2 instances. Yeah.
Can you wave at me because I have a hard time finding you? Oh yeah, there. Yeah. Thank you so much.
Yeah. So I had to create these EC2 instances manually, and I'll literally pause them and use them the next day.
Yeah.
I felt like if I had this library, it would have made my life easier.
Yeah.
But I guess my question is there like an instance where you can actually develop these keywords more, that you can bootstrap your EC2 instances while you create them?
Yeah, like currently I'm trying to focus on just wrapping what's there basically from Terraform and OpenTofu to keep it as flexible as possible. So right now, like if you're working with the Terraform library, you definitely need to learn about Terraform itself and how it works and how to deal with it, right? To keep it flexible. Like I have the fear if I add like more abstraction into the library itself, it might cost too much maintenance, but I'm very curious about feedback and ideas. Like if you have something very concrete, I'm very happy to discuss that.
Thank you.
And Niels will be also available. Okay, Tatu, let's be quick. Just yell out the question.
Well, my what?
The build.
Yeah. I'm still working on reducing it. It's.
But what's the number?
What's the number? No, I can't talk about it. Sorry.
So Speaker's Corner, he will tell the number there. Welcome to the team. Thank you, Niels.
Thank you.